hold up a coin. What if a black hole exactly that size appeared on your desk right now, weighing as much as the entire Earth? Look at it. A black dot, maybe a centimeter across, sitting where your coffee mug used to be. It looks like nothing. A hole punched straight through a photograph. But here's the part your brain refuses to accept. To make a black hole that small, you'd have to crush an entire planet down to the width of a marble. So the moment it blinks into being, it already weighs as much as the ground under your feet. Every ocean, every mountain, all of it, folded into something you could hide under your thumb. The danger was never the size. It's the density. And in about 15 minutes, that little dot is going to end the world, though not the way you'd think. So how does something the width of a penny kill an entire planet, and how fast? For one strange second, nothing happens. The dot just sits there, humming with the weight of a world. Then physics remembers itself. Think about what's holding it up. A desk, a few millimeters of laminated wood, now asked to support the entire mass of the Earth. It doesn't even slow it down. The black hole drops. It punches through the desk, through the floor, through the concrete foundation, through solid bedrock, like all of it were warm fog. Nothing solid can stop it, because no material that exists is strong enough to push back against a planet's worth of gravity packed into a single point. So it falls, straight down, toward the one place everything falls toward, the center of the Earth. If gravity were the only thing in play, it would reach the core in about 10 to 15 minutes. But long before it ever gets there, the killing has already started, and not from under your feet, from the heat. Here's the twist the movies always get wrong. A black hole doesn't reach out and grab things. It can only devour what falls directly into a target smaller than that coin, which, on the scale of a planet, is almost nothing. So Earth is never going to be neatly swallowed. It's going to be cooked. As the black hole tears downward, it drags rock, metal, and magma in behind it. That matter doesn't fall in cleanly. It crowds together, spiraling toward the point, crushed tighter and tighter until it begins to glow. Not red hot, not white hot. About 100 million degrees, roughly 10 times hotter than the core of the sun, burning right there inside the planet. And matter that hot screams. It blasts out X-rays and gamma rays in every direction, a furnace buried alive in the crust. So, while you're still waiting for something to be sucked in, the ground beneath entire cities is being cooked from below, radiation pouring up through the rock. The black hole kills with light, long before it kills with gravity. That's the part almost no one saw coming. And it gets stranger, because that infalling matter doesn't just heat up, it organizes. Anything spiraling toward a point speeds up as it crowds inward, the same way a spinning skater whips faster when she pulls her arms in. So the rock and molten metal funneling toward the center flatten into a whirling, blazing ring, an accretion disk, the same structure that powers the brightest objects in the universe, now spinning inside the Earth. Up to 40% of everything that falls in doesn't vanish at all. It converts straight into radiation and floods back out. And here's the cruel feedback. All that outrushing light pushes back on the matter still trying to fall in. So the planet doesn't collapse in one clean gulp, it fights itself. Meanwhile, the black hole now sits near the heart of the Earth, carrying a second planet's worth of mass, which means the gravity pinning your feet to the floor has just doubled. Far overhead, the moon feels it too, its orbit lurching as the thing it circles quietly became twice as heavy. The whole planet has started falling inward, toward a point you could have covered with your thumb. So this is how a world ends, not with an explosion, but with a slow, blinding collapse inward. The outer layers of the planet, the crust you live on, the oceans, the air, are flayed away by radiation, blasted off into space as the furnace at the center burns hotter than anything Earth has ever held. Underneath them, the rest falls. Mantle, outer core, the molten heart of the planet, all of it spiraling down into a point smaller than a coin you started with. There's no fireball to outrun, no shockwave with a clean edge, just the ground splitting open into light. The sky fills with the glow of a star being born in the wrong place, and everything you have ever touched falls endlessly inward. The most violent thing that can happen to a planet, and it happens in near silence. A whole world pouring itself into a dot, like water down a drain that has no bottom. Now, you might be thinking, black holes evaporate, right? Stephen Hawking showed they slowly leak their mass away and eventually vanish in a final flash. So won't this one just fizzle out and spare us? Here's the catch. That escape hatch only works for tiny black holes. Hawking's leak is faster the lighter a black hole is. One as light as a small mountain would be flickering out right about now. But ours has the mass of an entire planet. Run the same math, and its lifetime comes out near 10 to the 50th years. A 1 followed by 50 zeros, longer than the age of the universe multiplied by itself. On any scale that means anything, it is eternal. There is no waiting it out. Long after the cooking stops, after the last of Earth's shattered crust has spread into a glowing ring of debris orbiting the sun, the coin-sized point remains, dark, patient, drifting through the empty lane where a planet used to be, having barely begun to feed. So, back to the coin in your hand. Could this actually happen? Here's the genuinely reassuring part. As far as we know, there's no way to make an Earth-mass black hole by accident. You can't fold a planet into a marble in your bedroom. The only things that collapse into black holes are dying stars far heavier than our sun. The penny between your fingers is going to stay a penny. But the thought experiment leaves you with one idea worth keeping. We fear the big things, the asteroid, the supervolcano, the giant on the horizon. Yet the deadliest object we can imagine isn't big at all. It's smaller than the coin you're holding. The danger was never the size. It was always the density, how much reality you can fold into how little space. So the next time something looks too small to matter, remember the dot on the desk. The whole Earth fit inside it, and it was still hungry.